So hi everybody and welcome back to some C++ tutorial series for absolute beginners. This is video 145 and in this video we continue with our repetition of the keywords. And yes, we are here on number 45. I hope what I'm doing here, if you don't know, I'm reading this question here, and then you can pause the video and try to answer it. And I will, of course, not pause the video. I will just answer the question. But after you finish with your answer, then you can start the video again and see how I solve this question. And of course, it is a repetition, but not only a repetition of the keywords which we learned in this tutorial so far. It's also an extension, which means you don't have to know these questions absolutely perfect. Probably don't know all kinds of things here because I extended, I add new stuff, and we are focusing a little bit more on this side of the CPP reference here on this side here, CPP reference com. And the reason for that is we want to learn, of course, the syntax so we can read the official C++ documentation papers, which means if you are able to read them properly, you can answer all C++ questions on your own, so you don't have to really ask anyone else anymore. But still, there is a long way to go, and the best way is just to repeat, try to learn some syntax, and yeah, we do it. So that's that, and let's get started. For number 45, it says here, what is the keyword for? And okay, I hope you know this. It's simple, I hope. Then write the syntax and use the syntax to make an example. All time when I ask you write the syntax, don't try to write it with from your memory. That's not the reason here. You can just open up a search machine, try to find the syntax, and then use it. So you don't have to memorize. Of course, if you have memorized the syntax, it's very cool, but I have not memorized it myself actually. I just watch it, or I know, let's say so, I know an example, for example, but important here is just try to write the syntax. You can just open up the page and watch what the syntax is and then use the syntax to write an example. Let's go on. And then what we should do, use the while loop syntax to make an equivalent code for your example. Yes, that we have learned as well, right? We can convert for loop to a while loop. That's a little bit work. Try this as well. So convert your example to a while loop and explain the examples on the page. When we go to the page, we will explain them. So I hope you did it. You paused the video, you tried it, and I try to answer here some of these questions. Of course, my answers are not absolute correct. I make a short form and only one example of many examples. So it's not absolute correct, but you will see it's still correct, even if it's not correct. That's okay. Okay, let's say, what is the keyword for? For is used in a for loop. All right, that's simple. And I say this one, and we have no other fors. So then write the syntax to use the syntax to make an example. And I said you don't have to memorize this one. Just go to the page, not this page. Let's go here to the for loops. Let's go here. What's that? We need this. We need this not. Should I keep this? Perhaps I keep this. And then we go to the for loop. I don't know. It's this one here. No, this is range of loop. This is the while loop. Here is the for loop. All right. And here, just we watch a little bit here the syntax. I hope you get slowly but steady used to the syntax here on this page, because that's one goal, that we get a little bit used to that, right? And the easiest way is you just copy that, but you can see here it says your formal syntax for a for, it's this one, and an informal syntax, which means this one is not the official documentation syntax, is this one. And when we watch this one here, I will talk in a short about this, but the thing is here, actually this one here is exactly this one, but it is a little bit more divided in parts. We will see what I mean with this in a moment, because this one is the official syntax. Let's copy this one here, and we should make an example with our syntax. Let's jump here. let's write here our syntax. I write here a comment. And now we should use the syntax. Let's see. Attribute is optional, right? That was the square brackets, and I don't know an attribute what I need right now, so I skip this. I write for that we need. Then it says here init statement optional. This one is a little complicated here in this case, because this init statement is not optional. This one is conditional, is optional, and we will see in a moment what this means, but I make an example here, like, oops, not so. Like so, I say, okay, my init statement is my declaration of my start value. That was the way I explained this in our tutorial. You can set a start value and it can be an X declaration, but must be not a declaration because you can declare it outside and use it here. But I make it a declaration in this case, int I equals 0. And then I know I have declared this variable with the start value 0. The next thing, it says here a condition. I need a condition actually. In my case, I said I less than 5, for example. Then I have this condition. I use this condition, which is your optional. And then I need a iteration. And let's see if this is also optional both. It says here iteration expression is optional, but I don't think that this is so really optional, but it says optional. Perhaps we can, there are cases where you can skip it. Careful, when it says optional, that means not automatically you can skip it all time. There are only special cases where you can skip it. Most time you don't skip this one here, because this is the number of loops you want. And in many cases, you don't skip this one here, at least not in normal cases, let's say so. Only in special cases, and we will see that perhaps later. And yeah, let's write it. So, and I say here, I increment, oops, not so. And then I say I increment, and we learned this shortcut I++. So you can see, and here it's the only place where I said, yes, you can use here a short variable, because this short variable is absolute defined for this for loop, and this is the only place where I said short variable makes sense, and there are some other places too, but this is one. And then it says, interesting, what happens now is we have defined this here to this point, and now we have defined a statement. But important is here are no curly braces. Can irritate a little bit too, which means a statement can be anything, but it says here only statement, which means it's only one. Because one statement would work, for example, if I would say std cout and I put out just I, and you see if you start this one here, it will work. I print out all the numbers 1 till 4 because I started with 0. It's working. But if I add here one more statement, which means say out I plus 1, for example, is also a statement. This is not working automatically, not, because this statement means here really a one single line statement, and it is anywhere described here, anywhere. I don't know where, but important is careful when you read statement and there is no curly braces. This means all time one statement, and in general, as a programmer, it's easier just to skip this one and don't think about this one. But of course, if you know it, and you will see that many programmers use it for one statement as well. But in general, I said it's easier for us to read when we just started with this curly braces. Just put it here, and then we don't care how many statements we have, because it will work. For example, if I copy this one again, press it here, paste it, add something, it will work. So, and you see it, no problem, right? So we have used the official syntax. That was the official syntax here. So we understand this. Of course, if we want add attributes, and like said, attributes, you can click, for example, here. Let's see what happens, and then you can see the square brackets, and then you have see if this attribute is working with the for loop, because not all attributes are working and there are special cases. So let's go to the informal declaration a little bit. Actually, this informal declaration, what you see here, let me copy this. Why I can't? Let me copy this one here too. Is actually that what I did here Okay, that's a little bit long. Let's make it so, and let's make it here. Let's make it so and so. And you can see this one starts here, it goes here till this point. And actually this declaration here, what you see here, is actually that what I made here. So we have here declaration or expression optional. This is this one here. Declaration or expression optional. This is this one here. And expression optional. This is this one here. But yeah, let's say the more correct it's this one here. But why looks this one different than this one here? Because here we have only one semicolon, which we should use. You can see the official declaration here. I mean the official syntax here has only one semicolon. So what's the problem here when we compare this one to our for loop? The problem is here, this init statement, you need to read what it says. Here, as a note that any init statement, and this one is the init statement till this point, init statement must end with a semicolon, which means if you define here an init statement, and my init statement here is this int I equals 0, because this is my initial statement, it must end here. And this one is actually my condition. This one is this condition, this optional, and after this condition it comes a semicolon, which is this one here. So we see that this one here at all is exactly the same thing like here, but it looks only different. And the reason for that was that this one was here mentioned as a node. So sometimes syntax is not clear when we see it at first. You have really read all this kind of stuff here through to understand it. And sometimes I don't know also what all this is, because you have really check all this description here, what they want or what they mean and something like that. So it's not all time easy, but step by step we get better. So we don't have to know all at start. And this default example what I make here is very famous. I think you made something similar like this, I hope. And we go on with our questions. That was the syntax. So we have talked about the syntax. Let's see, the next question was what? I should talk anything about, let's see, what was it? I should talk, oops, not this one. Yep, let's make here a little bit more space so I can find it easier. I should talk something about here. Write the syntax. Yes, we have wrote the syntax, and now use the syntax to make an example. Yes, we made an example. I hope that's cool. And now here, use the while loop syntax to make an equivalent code for your example, which means I have jumped now to the while loop syntax. First of all, I have to copy it, and then I have to translate my example to this while loop. Let's do this. First of all, what is the while loop syntax? Here I have opened it up. You go to the keyword while, click it, and the while loop syntax is just this one here. I copy this one here. So it looks not big, and it looks again not that what we know, because our while loop, what we know in our examples, have all time curly braces. And think about that example what I made here. This statement is just if it's one statement, but if you want more, just you need this curly braces. And we use most time curly braces even for one statement, and this is an easier way. All right, so this is the syntax what I mean. I hope you know all these things here. We have here attribute, which is we don't need it if we only on certain conditions. And while we need, then this and the condition anyway, and then here the statement. All right, I copied this one. I go to my main. I paste it here down and make here as a comment. Now I have this one, and my job is now to convert this one to this one. And you see here it says, where was it? Here in our on top statement would be just one statement, but when we need more, we use this curly braces. And the same goes here. It says just statement. There is again no curly braces, but in general, we use this curly braces here because we are using more statements. So if you are using only one statement, it will work without this one. But if you are using more statements, it will not work without curly braces. So that's enough for us to know. And now let's convert this fast. So I see again, my for loop has no attributes here. It's not here, so I can skip this part. Very nice. Then I start with a while. Let's see, while. Okay. Then it says here, I need a condition in my thing here. The statement condition here, optional, is actually here, this one. So I have to put this one in. I copied just this one here. Copy. I paste this in. All right. Now we have here a problem that's interesting, and then the statements comes. But let's finish this first. The statements in my thing are this one here. These are my statements. Copy. And I paste this one here. And you see this one is not working as well. You see here, for one statement it would work, for two statements it would not. So I make the same like here. I add here curly braces. And then, oops. Let's add here the curly braces. Let's put them here in this thing here. Let's make here a car format so all is fine. And we have still a problem. So I have still this I, and you can see here is something missing. And what is missing, you can see we have here on top something like called an init statement, and here I have only a condition, which means this I here I have to define, and this init statement we define outside, which means I can say here int I equal 0. It's my init statement. You see this int I init statement I can't define in condition, because you see the syntax says you can't define it here, but you can perhaps define it outside. And this should be equivalent to this one here. And how we can test this? We can make here, let's write here faster. Oops, not here. Let's write here faster, a new line perhaps. As it is, see out, and make here a new line, something like so. It's okay, and start. And what we see is an error. And what is the error? It's not equivalent. Oh no, I made an error. What is the error here? So it says here E is 0 at start point, while I is less than 5. I print out and I increment I plus O. Okay. So you see the error, and that was stupid of me, because I said here, okay, I can just copy this one here as my statement. That's true. And I said I have the condition here. That's also true. That was not the mistake. And I said here int I is equal to 0. So you see I have almost take all paths, but I forgot this part, of course, this increment path here, which means my code, what I have here, needs the increment, and this increment I put actually in this code here, because I can't put it outside. Why I can't put it outside? Because this scope will all time loop here again. So I have copied this increment as well. Let's copy this one here, and that's why my code was not working. And now when I start this one, let's check this one out. So I have not used all parts, but now you'll see both are equal. Output, this code is now equal. So this should be right, and we can check this actually here in our for loop too. When you scroll a little bit down, I have not showed you this one, but here it's the syntax, an equal syntax, how this one is. Let's copy this one, it's very good, and put it here. So, and let's make let's write it here and paste it here and make this a comment. And you see that's exactly that what I did, more or less. The only thing is I have forgot this one here, that was this iteration expression, which I should put in. And yeah, you can see we can convert a for loop, and I converted taking this syntax to this syntax, which is just a for loop. All right, I think that was our question. So let's jump here back, and here we are back to this point. Yeah, And let's see what we have to do until the while loop syntax to make an equal. Okay, this one we have done. We write a while loop and now explain the examples on the page, which means I have to jump here on the for loop and we have here examples. This one is an example. So here it says examples. Interesting is you can run even this code here. When you click here, run code, and then you have something like that. And then here you have the output, something like that. But most time we don't need this one. So I go back here a little bit and I try to explain now these examples. But before I explain this example, let me show you what they have here more. Here is an example, interesting example. This is just one statement, and here, this is the way it works, like this one here. When you compare this line here with this line here, you see this one is a special case even. Let's forget this one. This is a special case, sorry. We talked later about, or read this one if you want to know what it means, because they are talking about scope and in special cases. And let's see what we have here. This one is interesting to note that C and C++ have a little bit different things. If you want, normally many things what is valid in C, it's not valid. It's also valid in C++, but there are some places where it's not the case. And here's again one of these examples. But important is now these examples here. Let's see. So pause again the video here. I try to make this a little bit bigger. Try to figure out what this examples is, or go to this page here, go to examples and try to understand here the output, but of course skip the things which we have not talked about. For example, we have not talked about the structs and something like that. Here, this iterator, this vector, this kind of thing you can skip. But all other things we should talk, at least try to understand. And let's get to it. All right, so I hope you tried it a little bit. For example, here on the bottom it's just struct. You can skip this, don't worry about that. So here on top it says here, this one, you see this example is exactly our first, here, exactly this one. It is just one statement. There is no compound, there is no more statements in it. And that's why we have just one line without, without this curly braces. But you see, this is the standard thing, what almost similar to mine. It starts with declaration, start value, condition, and iteration. I have not talked about this ++i here in particular. But let's skip this one. I mean, we know this increment here, but in for loop, what's the difference if it's first ++i or I ++ later? And actually in a for loop, it doesn't matter. And we will talk about this later, but that's only in a for loop. Careful. In other places, it matters. In a for loop, not, because the for loop is calling this condition in a special order. That's so the shortcut here, but we will talk about this a little bit more in detail. Let's continue with our for loops. Okay, that was the syntax for this one. Let's see what's the difference here. Yes, that is new. That is a little bit new. Look this one here. Careful. And what you see here is what we have not see so many times, at least not in my tutorial, which means and you should learn this one as well. This can happen here. What we see here is a declaration, and then we have a comma, and then we have here another declaration actually, and then we have here an assignment, and then a reference to this one here. That can irritate many people when they see something like that, or it can irritate also this one here, an increment equal to. So you can see this kind of stuff. So let me explain what happens here, but it says here already, you can read this one here. And then it says here, yes, multiple names. You can see here we are declaring multiple things, but let's check this with our syntax. Is this allowed? It says here the init statement. And when you go to the init statement, you can see here it's an expression statement and then simple declaration. That was what I made, a simple declaration, for example. And then we have something like that. which may be a null terminate. And then you have to read a little bit more if this is really allowed. And here it says init statement must end with a semicolon, but it says just an init statement. And now to identify if this one is allowed, you have actually to dive a little bit more into this this expression statement, what exactly is an expression statement and how it is defined and so on. But you can see here in this case, let's make it short, it is allowed. And if you don't believe me, just copy this one. All time when you don't understand it or don't believe it, make this one, copy this, go to your code, go down, and then just test it. Just test it. Sometimes careful. When you test it, I showed you something. Let's see if I can see it here. Here, this one. There are sometimes these green lines. In my case, I have not updated my C++. And some are not working because my C is anything like, I don't know even what my is actually. But when you click here, start, for example, the code here on top, it says which version it is supported, right? There are different kind of versions, say 70, say 11 or 20. I think this one is not even updated because there is already a C23. You see, this code has not even a C23 here included. That's interesting. But whatever, that's not important right now. Important is that you should check also this kind of stuff here because this might not work. All right, let's see. In my case, I started and see, yes, it is working. So the output is this one. Let's explain this output here. That is the point what we can do here now. So the output here is just here. I hope you understand this. This is just a normal declaration. And let's read this declaration, which means you make an int I, you declare an integer I as an integer with the start value 0, comma. What is this here? This is a pointer. This P is a pointer to an int. And if you make a pointer here, it is also a direct initialization because a pointer can be initialized to a null pointer or you can direct initialize something, and they make a reference, which means pointer to I here, this one here. And this one here is not a reference, actually, it's called a address of operator of I. We learned this with pointers, right? It's a little bit difficult, but I think after you learn pointers, this should be not too difficult. This is just a pointer declaration inside this for loop. Then let's see, then we have again our condition, and then this one is again, normally we see all time this shortcut ++e or ++ anything. Of course you can write it other way too, and we will see even more complicated examples here down the road. All right, let's continue. I hope this one makes sense. And here we use curly braces. You see, even so, this is one statement. You can use curly braces. This one here. Here they don't use. And let's go to the next question. And it says here, you can see what happens here. We have not talked about this one. This is an array, but interesting is a string saved in char. We have not talked about this, how this works, because this is a special conversion. Which we have not talked. Normally we have an array and then we have array slots, and these slots are assigned to this value here. For example, most time we made an int value and an int starts here the values, but we will talk about this one in later. But interesting is the for loop, what happens here. So let's check this one out. Again, we have our start value. We have here a condition. This condition is strange. Why is this condition strange? Because this one can irritate people too. The reason for that is we have not talked about this. Perhaps I should skip, but I just say it in case. This one here is converted later. Yes, it's just converted so that you can use it. Sometimes this one is even converted to char, can even convert it to bool, but in this case it's just converted to this condition statement here. And then you can increment this one and we have again this output here. But let's skip this one. When we talk about char as an array and how you use this, then you understand this one very easy. So let's go on to the next one. We have not talked about vector. Let's skip this one too. And the last question, this one we skip anyway, this struct here. Don't forget this one as well. And let's see if we have this one is a special case and a little bit difficult to understand, because that makes this one is very difficult. You can pause here and try to understand this. So you can try to solve that. If you can't solve it, no problem. But it is so difficult that let's copy this one and test this even. All right. So important is here also, look what happens there. We have our init statement outside here. So, and if we copy this one, if we paste this one, if we test this one, and yeah, where's my new line here? Let's go here for the new line, and let's go here to this one here. Let's paste, make this one and start. And this output is a little bit strange, right? So we have here an output which looks strange. We have here loop start, and then it says loop test, then iteration 1, loop test, iteration 2, loop test. So this most confusing part is probably here, this output here. And let's try it. So the output is here, and we start to see it. So first of all, what we have here actually, we declare outside a variable int, and we will use this int here as an iteration. So this init value, let's say the iteration value is in this one. It's not the init value actually. Careful. And that's a little bit irritating here. Why is this not the init value here? Because here we have here an init value which looks very, very strange. It's this std out loop start. This one is also an init value. How we can know it? This one is an init value. And so the reason for that is when we scroll down, when we scroll up, and it says here execute init statement once. So this for loop will execute the init statement once, which means if this one is only executed one time, then we know this should be the init statement here. And this one is not executed one time, at least not per definition. And we can see this here. Here's again this output. Loop start is initialized, executed one time. And this one here is not executed one time. And then we have the output loop test, iteration 2, loop test. And you can see here it says, when we read here a little bit more, the executed statement and iteration expression repeatedly. So the other one, the statement, iteration, expression is executed repeatedly, but also interesting is the condition is also executed repeatedly. Of course, it's not set here, but why is this condition executed repeatedly? The reason for that is it must check the condition for breaking the loop. So actually this one is also repeated repeatedly, which leads that this one is only executed one, which is our init statement, which is strange because it looks like this, not like that what we expect. For example, like a start value. We expect most time when we read for loops, we expect a start values or something like that. In this case, it is not a start value. Very strange for beginners. And in general, it's also not so much used in special cases. So careful about this one. And then we have here this condition, and then we have here our iteration. And then we have a break statement here. And again, this if is again a shortcut with one break. I hope you know this. If not, no problem. We learn it step by step. So that was a little bit complicated. And of course, you have to dive a little bit deeper into this. And I want to show you this code here. Let's copy this one here. And here to this side here, you know, I showed you this side here, probably this compiler explorer. It's here, this godbolt org here on top, and you can paste this one here. I pasted it here. This is exactly the same code, I think. Yes, it is. And don't worry about this compiler side here. This one we learn in the future after you finished basics, after you finished intermediate perhaps also. No, let's say you start with intermediate, because you should know compiler a little bit to understand all in and outs, and then all the stuff in C++ becomes later easier if you understand this one as well. But this is just for intermediate and professionals, not for our basics. We are happy when we understand this kind of stuff here on the left side, this normal code. And yeah, let's get into it. Why I'm here actually is, here is one more option here. In real, I want to show you this side can be helpful, and this side is supporting different, at least it's supporting STD-C70, also interesting. But important is here, this one, you have here one more option. It says CPP inside. It's open up this one, it copies your code, what you have here. And this CPP inside, you know what happens here is it will create this one, this code again here on the right side, but it will tell you a little bit more what the compiler is doing. So it has a little bit more. So it's not like this compiler here, which we don't understand. That's not very important. This code here we will understand, because it's just the step what happens in between. When I start here, this CPP, you can see now, let me drag this a little bit on, and can I scroll this a little bit? Yes, I can. You can see now what happens is, okay, I should not scroll because we can't see nothing there, but I hope you can see what happens. What happens is it says, okay, you are trying to print this out. You see this line and this line of code is exactly the same. So there is, oh, it's not exactly the same. Here you can already see in the first line, it is telling you what the compiler is doing here. It is using this operator, which is this one. We have not talked about operator, so this one is still a little bit difficult to understand, but just an introduction. In future we will use this so you can understand a little bit more. So it says I'm using this operator because this is an overloaded operator. Like I said, an overloaded operator means this thing here, this output, using this one as an output is not normal. This is defined in C++, and this definition happens with an operator overloading, and then it says what it's doing, what the operator overloading doing, but we have not talked about this one. But it's just saying I take stdc out, I make this line, I take this one here, what you have defined here, then I print out this one, and so on. But important is here the for loop. Let's go here a little bit deeper into the for loop. So what happens here is it says, okay, you are defining int and 0. Yes, that's the same what I do. But this for loop here, let's watch this. And you can see here again, it starts with this operator. And to skip this, I explain you what happens here. It is taking this one as an init part, and then it makes a semicolon, and then this one looks really hard. This section looks really hard for beginners, but don't worry, that looks only really hard. What you see here, this line of code, we have not talked about static cast, that's why it looks so hard. In real, it's really not so hard. It is just long, but not hard. When I can select it because it's so long. I can't select it. Oh my god. Okay, let's scroll it a little bit down, and here now you get it. This is only long, very, very long. When I can make it. All right, till here. So this code, oh, not from here, from here. Oh my god. Oh my god, why you make this to me? All right, here, so we are. So this looks very long, but actually we have here just a static cast. So which means all this thing here, what you have here, we have not talked about character, we have not talked about static cast, but we have talked about const at least, and how to read std basic and reference. I think I should skip this. Sorry for that. That becomes too difficult for starters. You get more confused than helpful. Let's skip this part. Sorry, too difficult for starters, because we have many things not talked here about casting, chars, how they are converted. actually I want to just show you this side here, because this will be helpful in future very much, because you can see sometimes you can't see it here, but you will see here the steps between what happens. And one step further would be the compiler, and that's the professionals are using this one to understand really what happens with the code. And yeah, if you understand this compiler in the future, if you can become a professional, then you see exactly what happens with your value, what is called and why it's not called, and all this kind of stuff. But that is for future. Not as a basic beginner, there is a lot of weight. So let's go back to our easy for loop here. So, all right, I hope you tried this, and I hope you get a little bit better. Actually, we just know the syntax. If you understand the syntax here, that's a good thing. Then you have to know that you have read later here a little bit more, because you see this strange looking things here. I show you this one all time. This, what was it again? Here, this one or this one. The reason why I go over this one is normally many programmers use not stuff like that, because they use very simple. And why they use very simple? Because it's fast. The simple one is the fastest one. You define it, use it, you are finished. Very easy to read, very easy to understand. You don't waste time. So the simplest one is actually the best one, but there are cases where they will go for this kind. And as a programmer, you have to know that this can happen, because if you don't know, because let's say you have only learned this simple version and never saw something like that or something like that, you get hard irritated, which means you say, what happens here? Anyway, so I hope that makes this a little bit clear why we are doing this, why I'm showing this one. It's very important. But don't worry, as a starter, if you know this version, this is a good programmer will prefer this one here over the other ones, because it's simple, fast, and effective. Just so, because you are interested in just looping, you don't want anything else here. All right. And let's go to our questions. The next question would be, let's see what we have. All right, that was just one question which we finished. That's very taking time, but that was a very important keyword. For loop, it's all time. Let's say loops and for loops are very important. They are all time used. You will encounter them in coding many places, so it's good to know much about them. More, let's say more. So next statement, it says 46. What is keyword go to? Do you know it? And then it says here why we need it. And then you should ask what is keyword label? And then where we use it. When I say where we use it is, you can say both if you want, or just label. And then it says here, explain the examples on the page. So let's get started. I hope you paused the video, tried it, and here are some answers which are particularly right, particularly not, but we will see. First of all, what is keyword go to? Go to is actually a control keyword. Yeah, what I mean with control, flow control keyword. Let's write it. Flow control keyword. You see I answered all time differently. In this case, a flow control keyword. I will explain this in a moment, what I mean with a flow control. But if you know already what a go-to is, means you can jump from one place to another. And that is actually, you change the flow. Normally you would go, let's say sequence 1 1 1 1 1, and then you instead you jump, similar to like under conditions, but important is here it is called let's say unconditional jump or something like that, but we will see this in a moment when we talk about syntax. So where we need it, have you answered this question? And whoa, no, it says not where, sorry, it says why we need it. And actually, in general, I say the answer is, in general, it bad to use it, but there are rare cases where we can, where it's easier to use it. So that's my answer for this one. And the reason why I wrote in general it's bad to use it, because this go-to, I explained this in our tutorial, it's normally a more or less older keyword, and it was made in the past for skipping, or let's not skipping, for trying to go out of loops and so on. There are many different things, but they change this behavior with inventing new things, how you can go out or how you can solve it in a better way. So this go-to is more and more less used, and the reason why that it's more and more less used, because it can cause more and more problems, because we will see it in a moment why. So that was this here. So why we need it, where it says is why we need it. So in general, we don't need it. Wow, is my answer. In general, it's bad to use it, but there are some cases where we need it. And these cases I will show, so this answer is not finished. I will show you these cases in the examples. So here, what is the keyword label? Do you know this? Actually, label is not a keyword. So I hope you notice that label is actually not a keyword, because label, you need a label when you use the go-to statement, and the go-to will jump actually where you labeled, where you write this label key, label word, and it will jump to this place. This go-to is a keyword, but label is not a keyword. Label is just needed for this go-to statement to jump exactly where this label is placed in your code. All right, so I hope that was okay. Then where we use it, so like I said, this label, you use it in functions. You are careful, you can't use it in every place. We have to check where, so you can use it in scopes where it's defined, but not in other. There are special cases where you can't and where you can't. So let's say here, just one answer is in functions or in scopes. We will see what I mean with this one here, but the scopes is too general. That could cause problems. Let's write here one answer is one in functions, for example. Let's write it for example in functions, and now explain the examples on the page, and now we will see all that what I write, what I mean with that. Let's go to the go-to, and here, so first of all, the syntax is very simple. Okay, I hope this syntax is very easy. We have here attribute, which is all time optional, you can see. And this attribute we never see, almost never see in programming, in, like I said, in special cases. But of course, the syntax must be correct. That's why they have it here. And then the only thing what we need here is go to, and then we have this label. So the syntax is very easy. Here is the explanation. And you can see it says here also, here on top, more better, transfers control unconditionally. That was what I said with why we need it. No, that was what is the keyword go to. You should say it's a keyword which the control is controlled unconditionally. Interesting. Here this is a flow control. We have not talked about flow control so much. This is also interesting, but right now you should know this one. And here, impossible to, and this sentence is also very important here. Used when is otherwise impossible to transfer control to the desired location using other statements. Normally, this one was, let's say it's old. This sentence, what I mean with old is nowadays you can almost get out of all places without this go to. So that's what I mean with this is old. You don't use it nowadays too much because it can cause many problems, but there are really cases where it's still used, and it's even better to use goto than other solutions. And we will see this in a moment. So you can read here a little bit things, and you can see the use cases cannot transfer here where you can't use it. For example, you can't use it to go to in a try block, and there are cases where you can transfer the go to exit transfers control locations. Yes, you have to find here where you can use it and where not. And there are, like I said, there are places where you can use it and where you can't use it. Read this a little bit. I skipped this reading here and go to the examples so that I can show you all these kinds. So here's again an example. We go and try here. You can pause again the video and try to make the example. Skip this struct here. We don't need skip this struct as well. Jump to the int and skip all there where you see a struct. And yeah, we are anyway concentrating on the loop, which means we are just interested in how the goto is jumping, right? So concentrate more how the goto behaves, not what the structs are. So let's get started. We are here in main. We start with a declaration of a variable, and here is the use of a label. Here, this is the use case of a label, and it is called label. It must be not called label. You can use it whatever you want, but important is that you use it this way here. Label colon. That's the way to use it. And the goto can jump to this place. And here it says, okay, skip this one. It's just later for class declaration, or here a struct declaration object. And then we have here an output, okay, and the output subtracts 2 of a. That's interesting here in a moment, and you will see why. And then it says here if a not equal to 0. I hope you understand this one too. It's just an if. It checks this condition. And if this is the condition, says yes, this a is indeed not 0, and we see a was defined here on top. It's 10 at start. So a is 10, and then it goes to this place, will be subtracted by 2, and then this if statement is checking if 8 is 0. But if it's not the case, and in the first round it's probably not, then you see this goto is used here, goto label, and this goto says goto where I have placed this label, and the label is placed here, which means it jumps out of this if and goes back here to this point. So the compiler goes back here and reads from here again. All right. And you see this little example here is actually a loop. So the goto realized a loop. You can make a loop with a goto. And like I said, goto is a little bit old. That was in old days, but nowadays you would not make a loop like goto and then label and something like that. You would not make this. You would just use a loop when you want to loop it, right? This is the new thing, or what I said, goto is old, and there are other problems as well, but things like that, you don't solve this nowadays in this way. This was solved in very old days. We don't make this. We use here just a loop, and there are many loops, while loops, for loops, do while loops, and whatever loop you want. And actually, this is also a loop, even if it is not called a loop. So, next question. I hope you understand this one. You can try and run this to see that it's indeed a loop. And here on the bottom, actually, when we see this one here, this 10, D8, D6, D4, D6, here, this is exactly this place where it's looping. It prints out here. Yes, it prints out this one here, and then you will see. Actually, we have to go there. All right, I hope that makes sense. Here, it's printing out here, actually, this one here, not this one here. This is new line. Here, it prints this one out, and that's why we have here 10, D8, D8, D6, and so on. Right, I hope you get this one. Okay. And we go to the goto for loop. And here, that's interesting. Why is this loop? Try to understand this for loop here with the goto statement. We have here in this for loop, we have talked before a little bit about the for loop. And here we have also combined it with a goto. And pause this and try to understand this. I will explain this now. So first of all, what we have here, we have a for loop, just that one what we all time use. You see init statement, start value, then our condition statement, then iteration. Here we have a nested for loop. That's important because nested means you have one for loop and then it's calling another for loop. And we also made in our tutorial one example with this nested for loop. It was just an error where we called the array with two with what we called a two-dimensional arrays. This is one use case for two nested for loops, but there are many different use cases too. But important is now this one. Let's see what happens. And again, they use here the curly braces here. They print this out. They print just the values out, x and y. Okay, that's cool. And this one is the most important part here. So try to understand why they use this one here and why. And this is the case where a goto is very, very good. This is the only one of these cases where I said a goto is in general very, very bad. But here in this case, a goto is good. And try to understand why. And if you don't understand why, try to make the same code here without a goto, and then you will understand why this is good. Or make it even worse. You can try to make here a for loop, make here a for loop, make one more for loops and add one more for loop, and then use a goto, and then you really understand why a goto is really good in nested for loops. The reason is simple. You can just, let's say, here, think about this example again. We make a for loop, we make a second for loop, which means we are trying to find something. But we have here a condition, and this condition means if we found that what we search, we don't want search the full array of for loops, right? We want just stop at this point where we find it because we want not waste time. And the goto says, okay, if I found it, stop the complete nested array, please jump to the place where I want you to go. And in this case, this goto says end loop is the next place. So which means this goto says, don't care about what comes next in this nested loops. I found that what I've searched, go to the next statement. And this is one of these rare cases where I said a goto is still useful, but it was here. Where is it? I don't know. I wrote it anywhere there where I said here, in general, it is bad to use. That was this bad case, was this case, for example. Why is this bad? Because we have already a loop, so you don't need to create a loop with a goto. And a good case, but there are rare cases where it's easier to use. And this is one of these rare cases, one example. In this case, it makes sense. And this one can, if you have even more nested loops here, then this one would be even worse to use, not a goto. So you have to use even a goto here to, let's say, to make it easy for you to go to the next point without wasting too much time. Of course, you can make this one here without a goto too. That's possible, but you will see if you try this and if there are more nested loops that this code will blow up really high, because it's possible, but you have make many checks to accomplish the same thing what this goto is doing. And yeah, I talked much about this. Let's go to the output, and you can see here the output of this for loop is here. It goes here, it finds and then immediately stops here with this one, and that's it. It don't checks all other things what comes next. It just stops, goes out, and it's finished. And here the last one, what we have here, oops, sorry, what we have here, we have here a goto label 12. Okay, it's initialized here, and we have not talked about this one, no worry. And I think we skip this one here because we have not just talked about it. Yeah, we have not talked about this one here. Let's skip this one here. because it is here, you can read it what it means, because it's not very important that you understand this one here, because we don't know what an object here is, or now about class and so, but you can still understand what the goto label makes. It just jumps out of this scope here, and careful, we have here a scope. Why we have here a scope? Think about it, when you see curly braces can stand for their own as well, right? They can just placed here in your code, and they build a scope for the in this area, which means now you have a local scope, and that's why they say here jumps forward out of the scope to object free, in this case label free here. Anyway, that's a little bit about this one. I hope you understand the goto. The thing what I have not talked why it's bad, there are many here on the further reading. You can go here and, for example, try to read this one here. I click it and see what happens there. Okay, you can read this, but this page here, why it is bad, but careful, it can be that this guy is trying to explain it again in mathematical scientific explanation. That could be too difficult for starters. If you don't know this kind of stuff, don't worry. Just keep in mind, avoid goto in general, but there are really cases where you need it, and one of these cases, for example, this goto. In general, try to avoid it. For example, like I said, don't create a loop with goto. You can just use a normal loop in this case here, which we learned. There are different kinds, while loop, for loop, or whatever loop. You don't need to create something like that. But here, that's the best solution with goto. In this case, I would say, when you have even more nested versions, that can be really hard without goto. It's possible without goto, but really hard. And yeah, let's go on to the next question. I hope 46 is done. Let's go to 47. It says here, write the syntax of an if statement and make an example. All right, we are in if statements. I hope, again, when I ask for syntax, don't try to memorize it. Just open up here this page, so try to find any syntax which you know. We have already talked about this if statement, so I will not go too much to it. We have already talked about this a little bit, but here I think when we talked about else, we have also talked about this if. And then the thing what you have to know is we have not talked about this const expression, and this is anyway optional. We have talked about these two versions, and we have also talked about why here is an else and why no else if is not defined. I hope you remember this. This was one of this repetition. And careful when you see something like that, watch this one too. It can also, in my PC would not work with this one because I have not updated this one here. And interesting is, let's see if they have updated it here. For example, run the code. And it says here just say C++20, but here to run this one, actually we need C++23. At least they point this one out. I'm not sure if they can run it when they have not it installed here. So probably they make no examples with this one here. They avoid this kind of examples. Is this the true? Probably. Yeah. Anyway, so let's answer the question. So it says here, write the syntax of the if statement, make an example. Let's write it again, what we know. Let's make this one here. Or let's make this one here, and then doesn't matter. This both I hope you know both of them. They are simple. So let's write the syntax here. I write it. I copy it, and make an example. Let's make an example fast. Again, attributes is optional. If I have to use, let's write here if. Let's copy this. Let's make this one here in our main, because it makes no sense to make it there. Let's make it here. I paste it here, and now I can use an example without making comments. So I have here this one here, and then I write if. Okay, I write here if. Then I have my const expression is optional. I can kick it. Then I have here my init statement and condition. I think this one is new. careful. We have here, is this new? Let's see. No, it's not new. But we have here also possibility. We have not talked about this one here, I think, that an if statement can have an init statement. We have only talked about condition normally. And let me show you what I mean without init. So what I would say, for example, is we have defined n here on top, right? Let's say here I use this n from top here and say if n is less than, I don't know, 0, then you can do something. And then I have used all time this curly. Why is this here? Expected declaration. What's going on? Why is that? Let me see what the problem is. Easier to see the problem when you just start it and it will jump. Oh no, there was no problem. It was just a bug. All these red lines was a bug. It was a little bit irritating. Okay, and now it's back again. Oh my god. Whatever. Let's start this one more time. Let's get rid of this red lines. Irritate me on the... Okay. Let's go on. Let's ignore this red lines. So when we have this one, here the syntax, we have here our condition block. This is just a condition what I write. Without init statement, you have to read again what the init statement in this case is. It's most time the same. Init statement, and you can see here, I think I talked about this one as well. This would not work on my PC. It says here since C17. So if I would try to write here an init statement, for example, an init statement is an expression, a null statement, or simple declaration, which means if I would write here int I equals 0, semicolon, that will not work on my PC because I have not updated it. And yeah, that's the problem. You have to check yes, something like that. And you see they update the C++ all time. Crazy is this one here. I have not C23 now. I mean, they have not even used the 23 version here, C++ 23. But they are saying this works only with 23. That's a little bit crazy, but yeah, happens. So with that said, I can't even test this code with this init statement, but I think you can test it if you have updated, or I showed you that you can use, if you want test code like this one here, you see this one is C++ 70. This could test it. Because I have it here with this init statement. Perhaps we go there and use this one, this compiler here, this online compiler, and or any online IDE which is supporting that, so you can use that. All right, let's go on with my example. Here is my example, and it's finished, almost finished. And C SVD, C out, and I print something out again. Test is it works. Let's make it works. All right. And let's make all time a new line because we need most time a new line. Okay. It works. And when you started, so we did this. So statement again true. Why it says statement true here? Ah, okay. That's very important. I forgot to tell this. Here it says statement true, which means this one will work only in this thing here if you set, for example, let me show you this syntax here has no curly braces, right? Which means you have this one here. This one is the syntax which they are defining, and this one, so statement true, means here this one will only work if this one is true in this case. And when I run this code now and it says here nothing, it works, is not printed out, which means this one here is not true. But when I say here greater, this one will become true because it was before not true. Then it should print out it works. And it says here it works. All right, so we have covered this one too. And this one, it's still irritating me why they are showing me this one. Okay. Okay. I don't know what's going on. Anyway, I kicked this anyway out because it's annoying me. We have anyway tested this all things. All right, so all gone. So we have made this one here, this example, and I think you know this one as well. This is the same thing, but an else statement, which means statement false. So you can make an else. And here one, again, we have talked about this. We have not a if else statement here. Normally, you know, this if else is a combination of this one here plus this one here again. Right? Let me show you this one at least again. That's very important that we understand this one. That was, I think I talked about this, but this is important that you understand this one. It's not so important, but it's still good to know, I think. So here is our syntax. And again, I write here if true, for example, no, if false. I can write something like this too. This one here, it's possible that I just write directly what I want. And here one more note, if I write nothing, it's by default true. So I can use this one, can I? No. Interesting. But we will see this one in a moment. Let's say if false, and then, oh yes, std cout is false, false. Something is false, let's say is false, because it's a little bit more clear. Oh, come on. And then I have this one here, and here, this syntax says here, okay, you have skipped this one, yes, I don't need it. Then you have used this one, yes, I need it. You have skipped this one, yes, I don't need it. You have used this open braces, yes, I need it, this open braces and closing braces. You have skipped the initial statement, what is that? That was here, sorry, here, this initial statement optional, yes, I skipped it because my PC is not supporting this one. And then you have used this condition, yes, I used this, the condition here, I set it directly to false. And then you have used statement true, yes, statement true is here. And then you have used the else, no, I have not used the else, but now I use the else. And then you can set a statement false. Yes, I can statement false. For example, std stay out. Oh, fuck. That was wrong. True, sorry for that. And here is false. So, and you can see here, I have no curly braces, and that's only possible when I use one statement. But as a beginner, I said it's not good. We should use all time these curly braces. It's easier to understand. And we know the scope in there exactly. Here, it's just, but still we get used to it. That's why I use this one here. And if I start this one here, we have a just if else statement. The question is now why we have not this one. If, and then this one. Let's say true. If I write this one here, it's the same like this one here. You will see it's false. And the reason for that why we have not is else if as a keyword is it is a combination about this one. After this one, it says a statement false or a statement true can be again a if. And the reason because is here on top it says if is a statement, which means you can add this as a statement, and that's why we combine this else if. And most time beginners think this is also a keyword, but in this case in C++ it's not. It's a combination of this one and then they just combine this one. And I think I showed you this one, right? I said you can rewrite this one here as a separate statement. Like so, and that makes it a little bit more clearer. Now you see it, we have the if, else, and here, this one, this definition ends here, but the statement here, it starts a new if else statement here. This is a new if else, a nested, you can call it a nested if else here. And that's why we have not a real else if statement, but you will see in programming, not this form, in programming you see, oops, in programming, you will see all time this form here, right? So that you understand. But I think that's anyway clear. That's anyway the easier version. And of course, this one is still bad. we should use this curly braces to make it easier for us as starters and easy readability. So you can just read it through, you see the scope, and you understand it very easy in this way. Of course, the other way, it's very important too to understand. So let's go on and see what I have to do, because I talked so much again. Still important, but I need to go a little bit further, right? So it says here where I stopped. It's the if statement, write the syntax of the if statement. Yes, I copied this here. Let's copy this one here too. Then I have at least one answer for this one. This is just one syntax, of course. Like I said, it's not all time correct, but you know what I mean when I say not correct. It is correct, but not exactly. All right. And here we go on and make examples. Yes, let's show the examples. Instead of making examples, we show the examples. And let's see, we have here many examples actually. Let's see if we can skip some. Here we have an int main. Try to read this and try to understand all which has not a struct in it. Let's start here. Let's see what we have here. Okay, let's start with the first block. Try to pause here and understand this. I think this one is fairly easy. This is exactly what I showed you more or less here. This is the first definition. The first one is our first syntax. If you skip now this one, if you skip this one, if you skip this one, then you have exactly this syntax here. This is this one here. And without curly braces, just a statement. And they use the second syntax actually. Sorry, this one is the second syntax. Till this part, it was the first syntax, and this part is the second syntax with the else statement, which means this syntax here. And then, yeah, then that's it. And you see, again, here no curly brace is possible because after this one, they start. So let's go. Here it says nested if statement. I think that's also not too difficult here. You understand this. And this side here prefers not to use curly braces, but yeah, you see when you not use curly braces, it looks like this one here. It is nested. It is sometimes looks a little bit not so clear. I personally like curly braces because then I see the scope and I know exactly what belongs together. In this way, it is just less code because you don't use curly braces. And if you get used to this one, it's also okay. And you need to get to use this one, not because you should use it, but perhaps other programmers are use it. All right, that's very important to know this code as well. So I hope this makes sense. We have here a nested if statement, which means they start here with a if. They start here with a if again. And interesting is they have not showed the other version where you can start here after the else with the if again. I think they show it a little bit below, and that's why they showed it not here. But this one is fairly easy to understand, I hope. We have here if, we have our condition, we have another if, we have our condition, we have our output if it's true, else, and this is false statement. True statement, else, false statement. And we skip this one here and skip this one and skip all these other things. Let's see, the output here should be clear. Then if statement with initializer. And this initializer, what you can see here is that what it's not working here. That's very important. That this code here will work only if you have C++70 installed, one thing. And here is one other problem. What I wanted to show you is here, I think this example looks complicated. It's actually normally easy, but we have not talked about something here what is defined here. That's why we skip it. The only thing what I mentioned here is this one is not working on Windows machines because this example comes from a Linux machine. Probably in Windows you have to use another library, and you have to Google how they use it. Something like, yeah, you must be careful. Not all works with the operating system as well. So there is not only the problem with that it's not the same version. Sometimes it runs, there are some libraries made for special operating systems, and other operating systems use other, let's say, libraries. Yeah, you will see this if you try this. I can't try it anyway. That's why we skip it. You should skip this. We have anyway not discussed about many words here, this auto, and then we have not defined how access for members. But if you have already knowledge, you can try to understand this one as well. So here we go here to const expression if. What's that? Here we skip it directly because templates we have not talked. It's a cool thing, but it's a little bit complicated right now if we have not talked about it. Interesting here is we have not talked about this ODR use. You can read this ODR a little bit. It is not a keyword or something like that. It is just, let's click it and show what it is. It is a definition. Let's see where we are here. Definition and ODR, one definition rule. Yes, it's a definition. And ODR, it means here one definition rule, and you should read this here a little bit what it means. In general, it means you should have only one definition in your program for declaration, for example. But a little bit more exactly, you can read this one here, what this means. And all time when you really see this green lines here, check if your IDE is supporting this one, because they are this word concept or something like that. There are newer words. It's not supported on all machines like mine. Okay, that's something new. We will talk about this one definition rule again a little bit more in detail in this tutorial, but not right now. But of course you can read it, and like I said, easy. If you want to know it the easy way, it is just that you should know for all things you can have only one definition, which means, for example, if I define here int x, then I can't use int x again, because it should be only one time in your code defined and declared. All right, let's compare this one. That was this ODR rule. Let's go here a little bit more. Let's see what we have here. Yes, we have not talked about this extern keyword. This is linkage, and let's skip this one. And we have not talked about this one as well. But here's just a normal if use. Const expression, we have not talked about const expression, but this const expression is similar to const. The only difference is, yeah, we will talk about this one. It has more features than const. And sometimes you need really both, and that's very strange. Const and const expression in very rare cases. But normally you need only const or const expression. That's why we skip this one here. And then we skip this one here. We have not talked about templates. We skip about this one here. We have not templates. All time when you see templates, let's skip. Const E will skip. All right, we skipped many things here. So you see we have a lot of things to talk later when we learn this kind of stuff. But at least we understand the if statement syntax and so on. Here are some examples. Okay, interesting is it says here, let me run this code. What it says here, run. Let's run it. And here it runs, it says here. All right, you see you can't run this one. And interesting is it says here since 23, and you can't run it because they got only implemented seed ++20. Dang. Why they make something like that, I don't get it. But okay, they make it. Anyway, let's try to understand it. We can't run it, at least not here in this case, but we can explain it, I hope. So const expression, let's skip this, let's skip this, let's skip this. And yes, we skip this whole examples. And yeah, we skip this. We have not talked about it. And here are some notes, which I think I showed you this example here. Ask you why. Oops, why can't this one here? I ask you why this one has an error, and the reason is here when you read it, read declaration of X. And interesting is here in this example, why is this an error? Normally you would say, wait a minute, here we have a scope, and if I declare in a scope an X, that should be not a problem, right? We learned something like that. Is this true? Normally, yes. Let me show you what I mean. Let's copy this one here, because this one can irritate beginners, because we learned something like, let's kick out this one here. and paste this one in and see what I mean. I told you when I declare int x, for example, int x, and let's say 5, let's make a programming variable name. I don't like the short. Let's say int my telephone number, my telephone number, and that is this one here. And now I can use my telephone number again if I use this curly braces here. Like that I told you, right? And why we can use this again, I told you the reason for that is this one, these curly braces are defining a scope, a local scope, which means I can just do this one here. I copy this one here, I paste this one here, and I stick other numbers here, for example this one, and I start this and there is no error. You see, no error at least, because that's possible. The problem is here, uncomment, and here we have an error. Why we have here an error? Okay, this one is not defined, f is not defined, but I make not a function now. Let's say x is 5, just the case, or 4, and still it says here error redeclaration, it says error redeclaration, and the reason for that is this scope in a if is not treated like a separate scope, which means this if is connected to this scope here. And you can read this a little bit more, and don't be irritated with this scope here. This scope creates all time a local scope in general, so that you can see this one here and this one here is working. But if and some other keywords make an exception, and if is one of this exception, you can see int is connected to this condition here is connected to this scope, right? We have to learn about this kind of stuff too a little bit, but don't worry too much about it. If you make it wrong, the compiler will say you can't do this like it did here. So I think it's time for me to make again a break. Even I covered only yes to this point here. Again, less. I start to talk much, I think, in these cases. But yes, it should be a repetition and an extension, so it's not just a repetition. We repeat, and the most thing what I try is that you repeat the syntax, like you can see, and these examples. And the most thing is that you understand the syntax, because if you understand this one and if you understand these words here, you will be able to understand in future the official C++ declaration. And then that's the primary goal, so that you can just watch all things on your own and don't have to ask anyone. Okay, with that said, I think I stop here. And if you have any questions or any complaints like all time, or any suggestions or any tips and tricks, perhaps write this in the comments. I will try to use them or explain them or whatever. And with that said, I hope you understand much more than me, and if you read the documentations and if you read a little bit in other online resources in C++ books, then you probably understand much more than me. Then yeah, you will get better in programming soon. And yeah, with that said, good luck, don't give up, try, and see you in the next. Bye.